Dear colleagues, good afternoon. I'm very proud of being a part of this meeting, and I should thank the organizing committee and Alison Waters in special. Emerging and novel blood products. I think I would be happy to say that apheresis plasma should definitely be a new blood component in Ireland, but it's not included in this lecture. My conflict of interests, I have been working together with several companies concerning blood components, but I hope I'm open to all. Well, definitions are needed, I think. And the word emerging, I think the emerging pathogens, they already exist. And that's the same with the blood components. They already exist in some part of the world. So the word novel should be novel to us in Europe, not novel to, for instance, developing countries with few resources. And I would also like to say that I don't distinguish between blood products and blood components as done in the Blood Directive. I'm going to talk about whole blood, red cell concentrates, platelets, plasma, non-DHP blood components, pathogen reduction, other blood components, and finally Irish perspectives. From EBA survey, whole blood, platelets, and dried plasma were the key issues. Whole blood, why did whole blood disappear as a blood component? Obviously, there was a need for cellular components. The cancer patients needed platelets, the anemic patients needed red cells, and there was a huge need for plasma for fractionation, just as it is of today. But I think, unfortunately, that the patients with critical bleedings, they were forgotten. Instead of blood components, they were treated with clear fluids. And maybe the reason is partly, at least, in this figure, because as you can see, this is the normal hemoglobin concentration, and this is the degree of reduced hemoglobin concentration. And you can see, even if you have 20% of your hemoglobin left, you still have good oxygen availability. And the lactate increase doesn't appear until that level. So why didn't this work? I think the key is in this word here, normovolemic, because the critically bleeding patients are definitely not normovolemic. So physiology was misused in a way. When we now go back to whole blood to reintroduce this old friend, what is whole blood? What are the storage conditions, and what is the storage time? And I think the terminology is very confusing. Warm whole blood is used, for instance, in the military, where blood is donated by one soldier to treat a wounded companion soldier, but that's not relevant for us. Fresh whole blood was used in the earlier days, and the definition was whole blood stored for less than 24 or 48 hours. The current terminology is cold stored whole blood. When we talk of introducing whole blood, that's what we intend. But unfortunately, there are different storage solutions, and we should distinguish between CPD and CPDA. And then we have the word whole blood for emergency, low theta group O whole blood. And I think that's also very much used, and I think that's what we are considering when we want to reintroduce whole blood. And then it is possible to leukocyte filter whole blood, but some of the filters also remove the platelets, and I don't think it's correct to use the term whole blood when platelets are not present. But there is a filter that is platelet sparing that can be used for whole blood. The storage criteria, the European Directive of Quality Management, the Directorate of Quality Management, they have defined that whole blood should be stored in the cold between 2 and 6 degrees Celsius. And if you have the CPDA solution, you can store it for 35 days. With CPD, it's 28 days. But in this proposal, which is now out, there is said that if you leukocyte filter the whole blood, you must define the storage time by quality control, and I will come back to that. Then again, whole blood for emergency use. All agree it has to be blood group O, but does it have to be RHD negative? Does it have to be K negative? This is a publication from Mark Yeasler, who is a leading scientist and blood banker in this field. And he and many, many colleagues think that in a situation where the patient has a critical injury, critical bleeding, may die from bleeding, the RHD issue is unimportant. And I can agree on that, but we shouldn't have the easy way. We have to consider the possibility of providing D-neg red cells or whole blood also in an acute situation. Another very important issue, at least theoretically important issue, is the question of titer, because everyone is using the term low titer. And we definitely know that anti-A and anti-B can cause hemolytic transfusion reactions. But unfortunately, there is no common definition of low titer. There is not even an agreement whether we should use IgG anti-A, anti-B, IgM anti-A, anti-B, or both together, although everyone agree that IgM titers are important. And the titer is depending on the titration method, unfortunately. So again, it's very difficult to find a common pathway. And I think the optimal solution would be to test for hemolytic capacity, because we want to avoid hemolytic anti-A and anti-B, but unfortunately, no suitable test is available. What about quality? The whole blood can be both filtered and unfiltered, and as you can see here, the red line is leukoreduced whole blood. The dotted line, blue, is non-leukoreduced. And when it comes to platelet counts, there is higher platelet count in the non-leukoreduced whole blood, whereas the mean platelet volume as a platelet activation marker is the same. And here you can see the glucose level is decreasing during storage, but it's not critical. You have glucose back, and you have the corresponding increase in lactate. The potassium concentration goes up, as it always does also in red cell concentrates, and the pH drops. And I think this is quite important, because pH of 6.5 or 6.6, that might sound good, but remember, the whole blood units are often or always given to patients with critical bleeding, and then introducing acidotic product is not very nice. So maybe we shouldn't always go for a long storage time, but the optimal storage time must maybe be shorter. The level of fibrinogen is quite stable, whereas factor 8 is declining, the concentration is falling. And a group of Dutch colleagues have said that you can only store whole blood for 15 days because of the loss in platelet function. But as we come back to a bit later, the platelet function may not be dependent only on living platelets. There may be, I think, microparticles that can be hemostatically active. When we are going to have the clinical decision-making, comparing risks and benefits of whole blood for transfusion, there are different strategies. Some would advocate that we should have ABO group-specific whole blood, because the advantage is that you will then have full ABO compatibility. But there is increased risk of hemolytic transfusion reaction due to incompatibility because clerical errors. And also, there will be limitations in donors because you can't have a huge storage of different blood components. And then there is a need for ABO grouping of both donor and recipients, and in acute situation, that is completely impossible. But if you use the low titer group whole blood, you have no issue on ABO compatibility, and there will be few ABO compatibility transfusion reactions, nearly none based on literature. And there is no need for cross-matching in an acute situation, and you have easily or rapid availability of the product, and it's much safer in a chaotic situation where you have to deal with a lot of other problems than just transfusion. And there is the risk of moderate hemolytic transfusion reaction. We have no good data, but based on data for platelet transfusions, it's around 1 in 120,000. And the risk of severe hemolytic transfusion reactions, I honestly don't know. In the Korea War, there was transfused 400,000 units and no reports of severe reactions. But at that time, there was no hemovigilance system available. But I think, what is your choice in this desperate situation you can come to in large bleedings? It's, of course, much easier with one bag than 3, and also there is less dilution in whole blood because you have additive solution in all the other components and only the initial dilution in whole blood. Then we go to the red cell concentrates. And for the first, I would say, is the red cell storage lesion of clinical importance? Oxidative damage, does it lead to hypoxic storage? And then we have the very important issue of non-DHP blood bags. As you can see from this very busy slide and complicated figure, the red cell storage solution is complicated, but in short, the membrane becomes rigid, the cellular surface is different, so that the red cells have difficulties in passing through the capillaries. So, but in clinical settings, it's been difficult to show the effect of storage time. But again, we can go to our Danish colleagues. They have those excellent the data sources, registers, as we were informed of earlier today. And in relation to the importance of the red cell storage time, they have been able to show, and I think that's the first time in the world, what I think must be obvious, that if you transfuse patient with short-term stored red cells compared to standard treatment, the survival in the patients are better and the morbidity is lower. So again, hypoxic storage may be part of the solution, and this figure shows the concentrations of 2,3-GPG in the red cells, and 2,3-GPG is necessary for the release of the oxygen. And in an acute situation, you definitely need oxygen to be released from the red cells. So here you can see that the hypoxic stored red cells have a high 2,3-G concentration also in day 21, whereas the standard product has a very low concentration. So maybe this is part of the future, and for, up to now only in vitro results are published, and you can see that they may be clinically relevant to us. Then platelet concentrates. When the dead awaken, cold store platelet concentrates, because cold store platelets concentrates were completely out of business. And for contingency, frozen platelets and platelet fragments can be extremely valuable. Well, the death of cold store platelet. This publication is iconic. It's from Murphy and Gardner, 1969. They concluded the use of cold temperature should be abandoned in the preparation and storage of platelets for transfusion purposes. And the reason is that the normal platelets have GP1B distributed over the surface, but in the cold they cluster, and then the macrophages just remove the platelets. But this removal takes around 24 hours, and in an acute situation, you don't ask, do the platelets work after 24 hours? You need them now. And we have some data on the quality of cold-stored platelets. And TEG is very much used. TEG is a whole blood measure of the hemostasis. You have a whole blood sample here. Then you have a flat line. The time is called R time, and it's dependent on coagulation factors. Then you have the coagulum forming, and this angle is called the alpha angle, which is linked to fibrinogen, and the maximum amplitude is linked to platelet function. And when we tested standard cold-stored platelets and delayed stored platelet concentrates, because it would be fantastic if we could keep the platelet concentrates at the ambient temperature for 7 days and then go over to cold-store the platelets. But unfortunately, as you can see, the platelet function is declining in the units that were stored first at room temperature. But the cold-stored platelets function well. So even on day 21, you have platelet function, although I agree with the Dutch colleagues, the platelets cannot be viable. And also the platelet count is well preserved, and the glucose concentration, you can see, goes down, and I think that's a critical point for cold-stored platelets. You need glucose until the end of storage, and lactate production or concentration is increasing. And this work, you can have more details in this very good publication from a US group. Then we go to the frozen platelets. And that is not a new idea. This is a paper from this same people who, so to say, killed the cold-stored platelets. They said that the platelet preservation by freezing is a good alternative. And I completely agree, because this is a product that can be stored for maybe 2 to 5 years and would be very good to have as a contingency, because it could also be available in hospitals not having platelet concentrates. And you start with the platelet concentrate, then you add the cryoprotective concentration, then you freeze the concentrate, and there are different protocols, and you can store at 25 degrees Celsius, minus 25 degrees Celsius or colder, and then you can thaw and transfuse, and the loss of platelets is only around 10%. And there are issues related to the DMSO because it's toxic, but now a Swedish group has been awarded an EBA grant to investigate different freezing media. So the future is really bright concerning these platelets. Then we go to platelet fragments. And thrombosomes are platelet fragments kept in tree halos and dried. So it's a kind of natural method for drying substances, and they are working. But unfortunately, there are some issues related to thrombotic side effects, so we don't know if this is the future. But if it works, it will be really good, because we should not be talking too much of the worst case scenario, but in case there is a nuclear event, many people will need platelets, and we have no contingency for platelets for the time being. Also, HLA depleted platelets, because if you have refractoriness, anti-HLA antibodies are the most prominent. So a lot of work is ongoing, and I just show this slide because it's been ongoing for many, many years, and the final conclusion is not yet there. But then we go to something that's really is important for us, and that's the blood bag without DEHP. And that is the EU requirement that will be the daily bread for us in a few years. And then we have the quality of the storage solution, because many of the storage solutions we currently use will not be able to keep the quality of the red cells. And this is a multi-center paper where also Barry Doyle participated from us. And in the new EDQM proposed quality criteria, there is a lot included, as you can see. For red cell, they suggest that we need to consider glucose, pH, hematocrit, hemolysis, ATP, lactate, potassium, and 2,2-GPG. And this cannot be done in a routine. So we need a plan how to collaborate to have this in place in due time. For as you can see, for blood platelets, the requirements are even more complicated. Most of us are able to do these measurements, but platelet activation measurement as P-selectin, beta thromboglobulin release, hypertonic shock response, morphology score, and extent of shape change are very difficult tests to perform. So we need definitely to collaborate where to go on, because this cannot be part of the routine evaluation and the routine validation of the bags. And then we have to define the routine quality criteria, because we, of course, must know what we should do before we can issue the components. And because there is an upgrade of blood bags, probably clinical studies are needed. So again, collaboration is necessary, because we can't all do clinical studies with blood components. Then we go to plasma. And dried plasma, and I don't differentiate between freeze-dried plasma and spray-dried plasma, they are now ready for us, and as is liquid plasma. I've just mentioned liquid plasma because it is an alternative, but I don't think it's very relevant for us. The dried plasma, and it's not new at all. Dried plasma was used during the Second World War, but as you can see from this picture, it's not very user-friendly. But the products we have today, they are quite different. They come as a kit with the dried plasma, and then you have the solution to get a fluid solution, and also the transfusion set. So it's very convenient, really, and it should be definitely considered, because it takes short time to dissolve the product. And as you can see from this table, the quality of the product is quite good. There is some loss of activity, but it's in acceptable levels, both for coagulation factors and for coagulation inhibitors. And now there is a safety study published, and again, the results are very promising, and you can see also the average time to reconstitute the plasma was only 67 seconds, so it's good for emergency use. For emergency use, you can also have liquid plasma, that is fresh plasma that has never been frozen, and it can be stored in the refrigerator for 7 to 14 days, and again, the advantage is that it may be issued immediately, and pathogen reduction of the product is possible. Pathogen reduction is available, and Barry Doyle mentioned it in the previous talk. And for whole blood, riboflavin is the method used, but unfortunately, you can't store the whole blood for a long period after it's pathogen reduced. For red cell concentrate, as Will Flegel mentioned earlier today, it's not available yet, but it's on its way. Studies are in the pipeline with a new synthetic cerulin. And for platelet concentrates and plasma, we do have methods. And the advantage concerning plasma is that we can make mini pools of plasma and then split into clinical components and can transfuse and make it whole at home, so to say. And just the riboflavin vitamin B2 is very similar to what has been shown earlier. You have the pathogen DNA, the riboflavin intercalates, and then you have a break of DNA after elimination. And this slide is already shown by Barry. I agree completely that blood cell manufacturing is very important, but it's really difficult because we have the final blood cells at the end, but on the way you need an environment, you need differentiation based on several growth factors and also interaction with the environment. So it's very extremely difficult to produce a sufficient volume. And this has also been ongoing for a long time, as you can see from these papers. But it's very promising what you also heard, that now in UK a clinical study is ongoing, but is going to be introduced. But unfortunately, if I have not misunderstood, the volumes of the cells is very small, so there is a long way to go. Other blood products, serum eye drops, we are proud to have introduced that already in Ireland. It's very useful for patients with dry eyes. And platelet lysate is excellent for cultivation of stem cells. And also in Ireland, there is ongoing work on that. And EBA has a project, as already mentioned. Finally, I want to highlight Irish perspectives, or I should rather say opportunities, because we can't do everything now, and at least not we could do it yesterday. But the IBTS, we are an organization with skills in all parts of blood component production and control. And that's a very good starting point. We have access to donors, and we have a research department which is really working very well. And in addition, we have excellent research partner, and we have excellent hospitals capable of doing clinical studies around us. And also, we need to strengthen one IBTS, and this can definitely be done, and will be done in connection with development of new blood components. And concerning whole blood, the program has already started. And there is, luckily, a demand from pre-hospital services. The initiative was taken by others than the IBTS, and I think that's always good that the initiatives come from the users. And this is a possible platelet source for all hospitals without platelet concentrates. And Ireland is not a big country, but the transportation time may be up to 4 hours. So we need to think contingency. And also in this connection, collaboration with Irish military can be crucial because we have the same goal to have a safe supply to the persons who need the components. And for the cold stored platelets, I'm proud to say that research is already ongoing, and there's a very, very interesting poster presented. So I hope that you all will look at that. And I think, again, the importance of the individual donor is highlighted in this research initiated from the IBTS, and that's, to my knowledge, not addressed by any other group. And this, based on the findings, you can see yourself by looking at the poster. It looks extremely interesting. And we have been talking all day about personalized medicine, how to better match the red cells and the patients. And also in this connection, maybe there are donors who perform much better than others in relation to, for instance, cold stored platelets. And we are very also proud to say that there's a large research project in collaboration with RCSI coming up now. And concerning dried plasma, there is a company now established in Ireland, so there are new possibilities for us. And for pathogen reduction, the validation of method is ongoing, as already told. And for blood cell manufacturing, there is expertise available in Dublin, and we are going to have a meeting in a very short time with this group. and then we will see what will happen. So the future is definitely not bad for us, because we shall work for improved red cell concentrates. We will introduce low titer group O whole blood for pre-hospital transfusions, and maybe for hospitals without platelets. And there are possibilities to engage in new platelet and plasma products for contingency. Concerning pathogen reduction, the final word has not been said, but at least when the method is available for red cells, definitely patient safety will increase. And concerning production of components not for transfusion, we will actively look for possibilities in that field also. And I think Alison Waters and her group, they guarantee that we will continue active research and development for new components. Thank you.
Thank you, Tor. So, open for questions. Tor, when I said earlier that surely some revelation was at hand, I wasn't expecting in a nuclear event many people will need platelets.
No, okay. But it's strange, but in the US there is a huge work ongoing just thinking of contingency, and that's been ongoing for many years. So many of these initiatives, I would say, unfortunately, come from the military because of needs that we don't want to think about.
Okay. Questions? I know it's late in the day. Don't be shy. Alison.
Thanks.
Yeah.
Sorry. Thanks, Tor. That was an excellent presentation. There's lots of information there on kind of new and re-emerging blood components. I'm just wondering if you had to prioritise one or two, what do you think should be the focus?
I agree with the EBA survey, whole blood and cold store platelets.
Tor, can I ask you, Dr. Flegel earlier said that it was better to be proactive and implement pathogen reduction, particularly for red blood cells. Where do you see that happening in the future? How reasonable is that to predict?
I am optimistic by nature, but I remember, you know, that when we said that we should have a replacement for red cell oxygen carriers, everyone said it's coming next year, but never. Every year, next year was the answer to the question. So honestly, I think within 5 years it's possible because studies have started. But the disappointments may appear, but it was tried about 15 years ago, and then it failed because when the red cells were treated with this Surland that was necessary for pathogen reduction, then the surface of the red cells changed so that new epitopes were presented, and unfortunately the clinical trial patients, they developed antibodies against the new epitopes, so that the project just had to close down. And but I think this time it's better, and I know that glutamine is added to the storage solution, and glutamine is protecting cells, so hopefully this time it works.
Right, yeah, question here.
I was wondering about intravenous immunoglobulin. Thank you very much. I was wondering about intravenous immunoglobulin. It's used as a therapeutic modality in several diseases, both hematological and non-hematological, and we now export intravenous immunoglobulin at a great cost, and there's sometimes an issue about availability. So is there any chance we will be producing our own intravenous immunoglobulin?
That is related to the plasma question, and honestly, I think we should feel obliged to start plasma pheresis donation clinics, because Irish patients and European patients, they are totally dependent on immunoglobulin produced from the US, and we know that there now can be restrictions on that export. So we need immunoglobulin, but I don't. I think if it may be produced in Ireland because there is a fractionation company establishing themselves in Ireland, so maybe there will be a plant, but I think the most important is that we collect plasma that is made available for immunoglobulin production so that the supply of the patients can be secured. And as said by Peter from the EBA, this is a pan-European challenge that we need to solve. We can't continue to be dependent on US, and already said, and again look to Denmark. Denmark has managed within a few years to establish a very good system for plasma collection. So I think there will be, in a foreseeable future, IBTS members will go to Odense in Denmark to see how this is working, and then we will have a similar system in Ireland. I'm quite convinced of that, although it's not gone through the formal process yet. I think we all agree that this is necessary, and we will work to get it on board.
Thanks, Tor. Just to I suppose come in. I think excellent speakers all day today. I've learned so much. On the good front, I mean, one of the good things I think about today is that none of us are going to be out of a job anytime soon, because there's lots of priorities and lots for us to do, and that's a really positive thing. And I think the energy has been terrific around that, so that's been fantastic. And there's lots of competing priorities is the other thing that's come up, that I've gotten that sense today. And I suppose just to say to everyone, whereas we don't have policymakers in the room today, but some of us will be exposed. Things like plasma is one. I think we will be doing a midterm strategy review in 2023. That is certainly something, whereas reintroduction of Irish plasma for therapeutic use was part of our strategy 2020 to 2025. I think that whole point about immunoglobulins, that's something we should, because I think if we've learned anything from COVID is that we do need to find a way to be self-sustaining, especially in things where we're relying on other countries, and we've all experienced that we do need to sort of shift the dial on that. But that will be a challenge for us as an agency. But I hope what everybody got today is we're up for that type of a challenge, but we need our government on board as well, and that's a part for us to play. I think, Brian, you might have mentioned that you can only go on that road if you've got support from your government. So one of the things that I would be saying is that's who we need to start influencing straight away. Is we are the people with the SI for collecting blood in this country, and nobody else has that. So we should be leaders in that one. I'm also excited about the whole blood and all the other pieces, and I thought Maureen's presentation was fantastic. I think the sickle cell, I think there is so much that we are doing and that we need to continue to do. So I just wanted to pass on my thanks. For me, it's been superb to just listen to the enthusiasm and the expertise that's in this room. I'm glad we're part of the EBA in terms of being able to do this along with our European colleagues, but also learning from those further afield. That was all I wanted to say. Thank you.
Thank you, and I fully agree. We had to address the politician, because we can't make our own money, unfortunately. So we need support. And in Denmark, they succeeded. So we should all over Europe try to do as they did in Denmark.
It mentions, well, it's almost going back to the future, because from the mid-1980s until 1990, the IBTS sent plasma abroad for contract fractionation to make coagulation factors, albumin, and immunoglobulin. So, yeah. Stephen, I'll give you the last word.
First of all, I'm delighted to see the progress being made and the ambition for the future. I think that's well done. Thank you. I just thought perhaps as a start with your apheresis plasma, you could think about with the introduction of pathogen reduction and the additive solution, you could still take plasma off those platelet donors, obviously with consent, and use that as your starting point.
Yeah, thank you. That will be done also, yes. So we will do all we can to increase the plasma collection.